In this video, we are going to look at some calculations involving mole ratio and reacting masses. Let's look at this question. Calcium carbonate decomposes when heated strongly, and the equation has been given here. How many gaseous molecules are produced? So the only gaseous molecules produced are carbon dioxide. Calcium oxide is a solid, so we don't look at it. We look at carbon dioxide. So how many gaseous molecules are produced when 10 grams of calcium carbonate is completely decomposed? And we know that 1 mole of any substance has this many number of particles, this many number of molecules, atoms, etc., right? So if it is 1 mole, we have got this many number of molecules. But with 10 grams of calcium carbonate, how many moles do we have? Now, to find the number of moles of calcium carbonate, all that we have to do is to divide the grams with molar mass. And molar mass of calcium carbonate is 100. So molar mass is 100 and the grams is 10, so which is equal to 0.1 moles. Now, if you look at the mole ratio of calcium carbonate to carbon dioxide, it's 1:1. They are 1 mole each. So if you have 0.1 mole of calcium carbonate, you have 0.1 moles of carbon dioxide. And if you have 0.1 moles of carbon dioxide, you have got 0.1 times 6.022 times 10 to the power 23 molecules of carbon dioxide, right? That many molecules of carbon dioxide. And 0.1 is actually 10 to the power minus 1. So, which is 6.02 times 10 to the power 22, right? Here is the answer. The equation for the combustion of ethanol is shown, as you can see it here. And the relative molar mass of ethanol is given, which is 46. Which statement about the reaction is correct? 4.6 grams of ethanol produces 4.4 grams of carbon dioxide, 92 grams, 88 grams, 108 grams. So as you can see in the question, they are not talking about the number of moles, they are talking about the grams of each of these substances. So it's going to be easier if we can write down the grams of all of these substances on the equation, just to make it easier. So molar mass of ethanol is 46, it's given here, right? Molar mass of oxygen is 32, but 3 times 32 makes it 96. And carbon dioxide is 44, so 2 times 44 is going to be 88. H2O is 18, so 3 times 18 is going to be 54 grams. Okay, so now it's going to be easier. Now we can just do the ratio calculations and find out if these statements are correct or not. Let's look at the option A, right? 4.6 grams of ethanol, which is 46 is 4.6, which is actually 1/10th of 46. So if you use 1/10th of 46, you're going to get 1/10th of CO2, which is 8.8, but here it is 4.4, so that's clearly wrong. Now, if you use 92 grams is 2 times 46 is 92, right? 2 times 46 is 92. So that is 2 moles, right? That is 2 moles of ethanol. If you have 2 moles of ethanol, you should get 4 moles of CO2. And 4 moles of CO2 is 4 times 44, right? And which is not 88. That is wrong. If you look at the next option, 138 grams of ethanol reacts with 32 grams of oxygen. You don't have to do any calculation. Just look at the values that we have. With 46 itself, you need 96 grams, right? 96 is way higher than 46. So with 138 grams of ethanol, you should definitely need more than 96, which is more than 32, right? So it's just common sense. You can do that. Or if you want to do a proper calculations, you can do that as well. 138 grams of ethanol is how many moles of ethanol? All that you have to do is this, 138 over 46, right? Which will give you 3. So you need 3 times 96 grams, right? 3 times 96 grams, not 32, correct? 184 grams of ethanol produces 216 grams of water. All right, so 184 grams of ethanol, and from the equation we know that for every 46 grams of ethanol, how many grams of water is produced? 54 grams of water is produced. This is ethanol, so you're going to get ended up having water. So that's 184 times 54 or 46, which is equal to 216 grams of water. Now that's the answer. The equation for the reaction between copper 2 oxide and ammonia are given. Copper 2 oxide, ammonia, copper, water and nitrogen, and you have the molar mass of all of those, and you have the atomic mass of copper. Which statement about this reaction are correct? Now 80 grams of copper oxide reacts exactly with 17 grams of ammonia. We can easily verify if that's correct or not, because 80 grams of copper oxide is 1 mole of copper oxide. So 1 mole of copper oxide reacts with ammonia, and they say it's 17 grams of ammonia. If it is 17 gram, it has to be 1 mole. So the mole ratio is 3:2. So if we have 1 mole of copper oxide, it should react with, for every 3 moles you need 2 moles of ammonia, right? So you technically need 2 over 3 moles of ammonia, and 2 over 3 moles of ammonia is 11.3, not 17. So that statement is clearly wrong. So if one is wrong, this is not the option, this is not, and this one is not. This is the answer. And you can also verify that by using the other calculations. Now look at the second statement. 4 grams of copper oxide reacts with excess ammonia to produce 3.2 grams of copper. So 4 grams of copper oxide, let's say 4 over 80 moles of copper oxide, that's the number of moles of copper oxide, right? And with excess ammonia, you don't have to worry about ammonia. So to produce 3.2 grams of copper, 3.2 grams of copper. So it's 3:3, which means they are 1:1. That means the number of moles is going to be the same as this. So all that you have to do is to multiply with the mass of copper, which is 64, and that is 10 and 8. That's 32 over 10, which is 3.2 grams, and which is correct. The mass of water produced in this reaction is greater than the mass of nitrogen. Clearly, because mass of water is 3 times H2O, which is 54, and N2 is just 28, which is clearly greater than the mass of nitrogen. It's correct. So the answer is D.